Today we're going to be talking about the graphs of quadratic functions, which are parabolas. Y equals ax squared plus bx plus c is the form for a parabola. If a is positive, the parabola opens upward. So it looks like this. If a is negative, it opens downward. There we go. Probably my upward one could look a little bit better. Here you go. Kind of looks like a horseshoe. The x-coordinate of the vertex is negative b over 2a, and that comes right from our equation. And the axis of symmetry is the vertical line x equals negative b over 2a. That goes right through the middle of the parabola. And actually, if you were to fold it in half, one side would be the mirror image of the other if you folded it along the line of the axis of symmetry. So let's take a look at an example. We have y equals negative x squared minus 2x plus 2. And we're going to start, well, first of all, we need to find out what a, b, and c are. This is like having a negative 1 in front of your x squared. So a is negative 1, b is negative 2, and c is positive 2. And if a is negative, we know that it opens downward. So it will be an upside down parabola. And now we need to find the x-coordinate of the vertex, so we're going to use the formula x equals negative b over 2a. So let's plug our numbers in. We're going to have negative 2 over 2 times negative 1, which gives you 2 over negative 2, so x equals negative 1. That's where we're going to start. Now, we're going to make a table of our x and y values. What we're going to do is we're going to start with that x value of negative 1. We're going to choose 3 values that are higher and 3 values that are lower. And we're going to plug them in to this equation. So we're going to start with negative 1. 3 values that are higher would be 0, 1, and 2. 3 values that are lower would be negative 2, negative 3, negative 4. Do choose whole numbers. And don't go crazy with any really high or really low values. I'm sorry, I should say really high values, or when I say low, like decimals or something like that. Just stick with whole numbers. Let's plug our numbers in. So we have negative 1 squared minus 2 times negative 1 plus 2. Because we have a negative in front of our parentheses, we do know we're going to end up with a negative first term. So we're going to have negative 1. Negative 1 squared is 1, but make it negative. Negative 2 times 1 is positive 2 plus 2. All of that gives you 3. Now we won't go through the arithmetic on every one of them, but I just wanted to do that so you would get the idea. So we have negative 0 squared minus 2 times 0 plus 2, which gives you 2. We have negative 1 squared minus 2 times 1 plus 2, which gives you negative 1. Negative 2 squared minus 2 times 2 plus 2. All of that gives you negative 6. Next, negative. Anytime you're plugging in a negative, put it in parentheses. It doesn't even hurt to put a positive number in parentheses. But you avoid a lot of problems this way by putting a negative in parentheses when you plug it into an equation. So we have negative 2 squared minus 2 times negative 2 plus 2, which gives you 2. Negative 3 squared minus 2 times negative 3 plus 2 gives you, as a plus, gives you negative 1. And negative negative 4 squared minus 2 times negative 4 plus 2 gives you negative 6. So because I used numbers that were just went in increments of 1 away from the vertex, notice the numbers did repeat themselves after the vertex. So 2, negative 1, 6, 2, negative 1, negative 6. And that's what it should have done. Our ordered pairs, let's list them. We have negative 1, comma 3. We have 0, 2. 1, negative 1. 2, negative 6. Negative 2, 2. Negative 3, negative 1. And negative 4, negative 6. So let's go ahead and do this. Let's graph our point. So we have negative 1, 3, which is right here, 0, 2, 1, negative 1, 2, negative 6, negative 2, 2, negative 3, negative 1, and negative 4, negative 6. And notice we are getting a horseshoe shape. Okay, and we do have an axis of symmetry. Remember, x is negative 1. That is our axis of symmetry, as well as the x value of our vertex. And so if we were to draw a line right down the center at x equals negative, or if we were to draw a line, I should say, down at x equals negative 1, it would go through the center of the parabola. And notice it did turn out to be an upside down parabola, just like we predicted. So let's take a look. Oh, by the way, let's just write in our axis of symmetry, x equals negative 1. Let's move on to another example. We want to graph y equals x squared minus 4x plus 5. In this case, a is 1, b is negative 4, c is 5. So let's plug in our numbers. X equals negative b over 2a. That's how we start this off with our vertex. So plug in our numbers. So we have negative 4 over 2 times 1. So we end up with 4 over 2. So in other words, x is 2. That is our starting point for our table. It's also the axis of symmetry. So let's make our table. And let's plug in our values for x, and then we have y equals x squared minus 4x plus 5. So we have to start with 2. We need to choose 3 values higher. So let's do 3, 4, and 5. And 3 values lower, which are 1, 0, and 1. And let's just start plugging 1, 0, negative 1, I'm sorry. And let's just start plugging our numbers in. So we have 2 squared minus 4 times 2 plus 5. Well, just to get you started off, 2 squared, it's 4. Negative 4 times 2 is negative 8. Plus 5 gives you 1. So our first point is 2, comma 1. I'm going to list my ordered pairs right here. How's that? So let's do the next one. 3 squared minus 4 times 3 plus 5. That gives us 2. So our next ordered pair is 3, comma 2. Then we have 4 squared minus 4 times 4, kind of messed that up a little bit, plus 5. And we end up with 5. So our ordered pair is 4 comma 5. 5 squared minus 4 times 5 plus 5. That gives us 10. So we have 5 comma 10. 1 squared minus 4 times 1 plus 5. That gives us 2. Notice the values are going to start repeating themselves. So we have, at least for the y values. So we have 1 comma 2. 0 squared minus 4 times 0 plus 5 gives you 5. So we have 0 comma 5. And then negative 1. Again, if you're plugging in a negative, put it in parentheses. So we have negative 1 squared minus 4 times negative 1 plus 5. All of that gives you 10. So we have negative 1 comma 10. Go ahead and graph that. Oh, by the way, since a is positive, a was 1, what do you think is going to happen to the parabola? Will it open upward or downward? Well, we know if a is positive, it opens upward. So let's see if we're right. Okay, so we'll graph this and see if that prediction was correct. 2 comma 1. It's right here. Then we have 3, 2. Oh, I went up an extra one. I'm sorry. I went up 3, 3. So 3, 2 is right here. And then we have 4, 5. And we have 5, 10. Let's do the next one. So, or the next set, we have 1, 2. We have 0, 5. And we have negative 1, 10. And notice we do get this horseshoe shape. If I had drawn it better, it would have been a better horseshoe. Okay. And the axis of symmetry we said was x equals 2, so let's just draw a vertical line through 2 on the x-axis. And that is your axis of symmetry. I'll just make that note right here. Okay, so by putting in that axis of symmetry, we can see that one part of the parabola is the mirror image of the other side. One side is the mirror image of the other. One last thing I want to tell you about, the zeros of a function. That's where the graph crosses the x-axis. Now, if you look at this picture, this graph does not fall across the x-axis. So we would say that this had no zeros at all. Now let's look at the one that we made up above it. Okay. Does this graph cross the x-axis? And yes, it crosses in 2 places. Those 2 places are the zeros. Okay. That's just a term that we're going to start using. Those are the zeros. So this particular function has 2 zeros. Okay? And those are actually x values. If you were to set this equation equal to 0 and solve it, those would be solutions of that equation. And we're going to get into that a little bit later. Thank you so very much for joining me today.